Good morning. Today we're going over 2.8 inverse functions. So what are inverse functions? There are one-to-one functions that are important because they are precisely the functions that possess inverse function according to the following definition. So the definition of an inverse function is let f be one-to-one function with the domain of A and a range of B. Then its inverse function is f of -1, has a domain of B and a range of A. That's defined by, you have f of -1 is the inverse of f of x. So your range is now the domain and your domain is now the range. So they flip. This is for any y in B. As we do more problems, it'll make a little more sense with the definition, so just bear with me as we go through the first few slides. The inverse functions, so this definition says that if f takes x to y, then f of -1 or inverse of f takes y back to x. If I were not one-on-one, then f of -1 would not be defined as uniquely. So the arrow diagram in figure 6 indicates that the inverse function reverses the effect of f. From the definition, we have the domain of f of -1 equals the range of f, and the range of f of -1 equals the domain. So for a normal f of x function, you guys are used to having the domain deals with the x values and the range deals with the y values. Now for an inverse function, it flips. Your domain is now the y values and the range is now the x value. That is all that this is stating, so it flips one to the other. So finding f inverse of specific values, we have if f of 1 equals 5, f of 3 equals 7, and f of 8 equals -10. They want us to find the inverse function of 5, the inverse function of 7, and the inverse function of 10. So if the original is f of 1 equals to 5, then the inverse would be f of -1. We're going to flip them. Your y now goes inside the parentheses, and your x now goes on the outside. So it's just the opposite. So I'm going to write the other one. So f of 3 equals to 7. F of 8 equals to -10. Now, the inverse of this one is going to be the inverse function. Now, again, since your y becomes your x, it's going to become 7. And since your x becomes your y, this will be 3. Same for the last one. It would be -10 for the new x and 8 for the new y. So right now, we're just changing what the domain and the range is. There is a way of solving for them, and we'll get to it further down. But for now, we're just flipping the domain and the range. So we're flipping the x with the y's. So the inverse functions, we let f be one-to-one function with a domain of A and a range of B, and the inverse function satisfies the following cancellation properties. So if the inverse of f of x equals x for every x in A, and the inverse and the function of the inverse of x equals x for every x in B. So conversely, any function of f of -1 satisfy these equations in the inverse of f. So this just means that they're going to cancel out. As you guys know, the inverse of a half is or 2 is a half, and if we were to multiply them together, they cancel out and we get 1. The same thing happens with the functions. I'm not gonna make a problem up just to explain that. We'll get to problems that we'll get there, but for now, just understand that the inverse cancel each other out like it does with any other number. So these properties indicate that f is the inverse function of f of -1. So we can say that f and f of -1 are inverses of each other. So these are the steps on how to find the inverse function when you're given a function. So we have write y equals f of x, solve the equation for the x in terms of y if possible, and now interchange x and y. The resulting equation is y equals f of -1x. Note that steps 2 and 3 can be reversed. In other words, you can interchange the x and the y first, and then solve the y in terms of x. I'll show you in the next slide the steps, and I'll tell you which step is which. So they want us to find the inverse function f of x is equal to 3x minus 2. Now this is the first step. We have to change the f of x into y. So y equals 3x minus 2. Now we're looking at the second step. The second step is now solving for x. So I'll go ahead and add 2 on both sides. So we're left with y plus 2 equals 3x. I'll divide by 3, and we get y plus 2 over 3 equals x. Now, the third step is to change the value. So wherever there's a y, we will write in an x, and wherever there's an x, we will write in a y. I'm going to first rewrite it with the x first. So when I rewrite it, it would be y equals to x plus 2 over 3. So this would be in function notation f of -1 of x, because this is our new y. We can change it into the inverse, equals x plus 2 over 3. In the notes, I have this separated into two parts. So in the notes, it looks like this, just so you guys know why it looks different. It's just x plus 3 plus 2 over 3. It's the same thing, I just separated the equation. You guys can leave it in either form, and it's fine. Just so you know, I just want to make sure you guys didn't think, because it's written differently, that it's wrong in this case. So here they want us to find the inverse function. So the first thing I do, first step, y equals 2x plus 3 over x minus 1. Now we're going to multiply x minus 1 on both sides to be able to get rid of it. So we are left with x minus 1y equals 2x plus 3. I will subtract the 3 on both sides, and I'm left with x minus 1 y minus 3 equals 2x. I will distribute that y. See if I can solve for it. So I get xy minus 1 minus 3 equals 2x. So xy minus 4 equals 2x. I'll move the x's to one side and then the 4 to the other. So I will be left with xy minus 2x equals to 4. And take out the greatest common factor of x. Then I'll divide by y minus 2. Divide by y minus 2. We get x is equal to 4 over y minus 2. Now that I've solved for x, I can rewrite it with the y. So I'm left with y equals 4 over x minus 2. And as the last step, I'm going to write it in function notation as f of -1x equals 4 over x minus 2. They want us to find the inverse algebraically. So again, I'm going to write this as y equals 2x plus 7 squared minus 3. Now, I will not deal with that square yet. I will deal with that last. So I'll start by adding the 3. So y plus 3 equals 2x plus 7 squared. I'll divide by 2. Y plus 3 over 2 equals x plus 7 squared. Once I get there, I'll take the square root on both sides. And I'm left with the square root of y plus 3 over 2 equals 2x plus 7. I will then go ahead and subtract that 7. I'll keep going right here on the side. So we have x is equal to the square root of y plus 3 over 2 minus 7. So now I can change them. So this becomes my new y equals x plus 3 over 2 minus 7. So this is now the inverse function of x equals x plus 3 over 2 minus 7. And that is our solution. I'll highlight it. Let's look at 2. I'll change the color so it's easier to separate. So this is now y equals x squared plus 4. I'll subtract 4 and we'll get y minus 4 equals 2x squared. I'll take the square root and we're left with the square root of y minus 4 equals x. Now this would be, let's flip them, x minus 4 equals y, all of that under the square root. And then I can rewrite it as f of -1 of x equals the square root of x minus 4. Now for 3 again, we're going to start with y equals -5x squared plus 3. We're going to start solving for x, so we'll subtract the 3 We'll subtract 3. We get y minus 3 equals negative 5x squared. I'll divide by negative 5, and we're left with y minus 3 over negative 5 equals x squared. Now I'm going to take the square root. So the square root is y minus 3 over negative 5 equals x. I'm just going to rewrite it. So the square root is x minus 3 over negative 5 equals 2y. So I can rewrite it as the inverse function of x is equal to the square root of x minus 3 over negative 5. So for number 4, we do again y equals 5 minus 3x over 2. I want to get rid of that 2, so I'm going to multiply it. So I'm left with 2y equals 5 minus 3x. I'll subtract the 5, and we're left with 2y minus 5 is equal to negative 3x. I'll divide by negative 3, and we're left with 2y minus 5 over negative 3 equals x. I'm going to rewrite it as 2x minus 5 over negative 3 equals y. So I can rewrite it as the inverse function of x equals 2x minus 5 over 3. Now again, guys, just so you know, on the completed notes, I wrote it differently, but it is the same thing. Oops, forgot the negative at the bottom for the 3. For the completed notes, just so you guys know, I wrote it as f of negative 1 is negative 2x plus 5 over negative 3. Over positive 3. The entire difference is I distributed this negative from the bottom and I put it on the top, but it's the exact same answer. So if you need to look back at the notes and they don't match with your notes right now, that's fine. It is the exact same thing. Notice how every single sign is flipped, so I just distributed the negative to the numerator instead of keeping it on the denominator. So, graphing the inverse of a function. We have the principle of interchanging x and y to find the inverse function also gives us a method for obtaining a graph of f of negative 1 from the graph of f. If f of a equals b, then f of negative 1, or the inverse function, is going to be b equal to a. Thus, the point a comma b is on the graph of f if and only if the point ba is on the graph of f of negative 1. So what we did earlier, we flipped the two numbers, we flipped the x and the y. So if you were to graph it, whatever your x originally was, that is now your y. And then vice versa. So in this example, we have graphing the inverse of functions, but we get the point b comma a from the point a comma b by reflecting in the line y is equal to x. Let's see figure 9. Therefore, as figure 10 illustrates, the following is true as well. So the graph of f of negative 1 is obtained by reflecting the graph of f in the line y is equal to x. You guys remember this from geometry? That line of reflection is just flipping the numbers. So if you have a point right here, which is b comma a, you have a point right there, which is a comma b. All it does is flip the x and the y. Same for this one. If you have this point, let's call it 3 comma 1. Now you have this point, let's just call it 1 comma 3 for as an example of what it could be. Alright, since there's no questions, you guys probably noticed I opened up your 2.8 homework. It is on WebAssign. It is 13 questions. And just as a reminder, guys, your test is on the 14th, which is on Thursday. And it's from 2.4 to 2.8. Tomorrow we'll be working on the study guide. And then your test will be on Thursday.